All right, so 6.4, sum difference. And what you want to recognize here is this is sine of some number, sine of some other number. And then we identify alpha as being 4x and beta as 2x. And then we will grab our identities paper and look for the sine alpha, sine beta. Here it is, the second one, sine alpha beta. And they want us to express this as a sum, plus or minus. So here it is. And so we will write this then as 1/2. We have cosine of alpha minus beta minus alpha plus beta. So same deal, but can you identify the new identity or the next one? So sine of some number, cosine of some number, and then identify alpha as 4x, beta 2x. We'll go to the sheet, look for which is the sine cosine one, and here it is, the third one. So we have alpha plus beta. So 4 plus 2 is 6. And then plus sine alpha minus beta. So 4 minus 2 is 2. So now we want to do this in reverse. So now we're going to take a sum and put it into a product. So same deal. Sine of some number plus sine of some other number. And then we identify those numbers. Alpha is 2x and beta is 8x. And we'll go to our sheet and look for which one is the sine plus sine. And that would be the third one here, sine alpha plus sine beta. And that equals. So we have alpha plus beta. So 2 plus 8 is 10. And then divided by 2 is 5. So the divided by 2 comes from right here, division by 2, just looking at the third identity here. And then cosine alpha minus beta. So now we have 2 minus 8. So that's minus 6x. Divided by 2 is minus 3x. And remember, those are in parentheses there, technically. And remember that cosine is an even function. And an even function means when you put in a negative value, it's the same thing as putting in the positive value. And another good reason to make sure that you use parentheses, unless you're really confident about your handwriting, is, sometimes people think you can take this 5 and multiply by that 2. And that happens sometimes. People do that. But that is not correct, because this parentheses here is technically, these are function notation parentheses. So those are not multiplication parentheses. Those are function notation parentheses, meaning like f of x. These parentheses don't mean multiplication. That's function notation. So what do we get here? And the same deal again. So we have cosine of some number plus cosine of some other number. And then we identify alpha as 1x and beta as 7x. And then we'll go to identities page and look for which one is cosine plus cosine. That's the first one. And we'll plug our stuff in. So alpha plus beta, x plus 7. And was that a 7? It was, for some reason I thought it might have been a 1. It is 1 plus 7. So that gets us an 8. Oh, and divided by 2. Divided by 2. So that's a 4. So again, looking at the first line here, alpha plus beta divided by 2. Alpha plus beta is 8x. 8x divided by 2 is 4x. And then cosine alpha minus beta, so that's x minus 7, which is a minus 6, and divided by 2 is a minus 3. And again, cosine is an even function. Oops. And an even function means plugging in the negative is the same thing as plugging in the positive. And we should be good to go. And same deal again. Now it's just fractions. Will fractions mess you up? So this is cosine of some number plus cosine of another number. And then we identify alpha as x over 2 and beta as 3x over 2. And that is not a 2. And we'll look at our identities. Which one's cosine plus cosine? The one we just did. And we will do it again, apparently. So I'll write this one out because we have fractions here. So we have alpha plus beta all divided by 2. And then cosine alpha minus beta all divided by 2. So they both have a common denominator, so we can just add them together. 1 plus 3 is 4. 4x divided by 2 is 2x. So 4x divided by 2 is 2x. But this is still all divided by 2 again to give us x. And then cosine. Let's see what we have here. So we have x minus 3, so it's minus 2x divided by 2, which is x, but it's all divided by 2 again right here to give us then a half x, or x over 2. Oh, that didn't work out for me. I was trying to see if I could get division in there. And the same deal again. So we have sine of some number minus sine of some other number. We identify alpha then as 5 pi over 12. and beta pi over 12. We'll look for the identity that is sine minus sine, and that's the fourth one. We have alpha plus beta all divided by 2. And then sine alpha minus beta all divided by 2. So just in case you didn't catch it last time, we can just, they both have 12 as a denominator, so we can add this together. 5 plus 1 is 6, so we get 6 pi over 12. That's still all divided by 2. Now we have 5 minus 1, which is 4. That's still all divided by 2. And six over 12 is pi over 2. That's still all divided by 2. And 4 pi over 12 is pi over 3, and that's still all divided by 2. Remember, division is the same thing as multiplying by the reciprocal. And so we get and do they want us to leave it, since we know pi over 4 and pi over 6? It does, well, let's see. Do they want the trig functions or the number answer? And they just wanted the trig functions. Oh, there it is. Find the exact value, since we know pi over 4 and pi over 6. That's anticipated there. So pi over 4, 45 degrees. Square root of 2 over 2. And pi over 6 is 30 degrees. And that's half. And we get 2's will divide out. We get square root of 2 over 2. Verify the identity. Start with the numerator. So what do we got? We have sine of some number minus sine of some other number. So they're telling us to do the numerator first. 3 and 7 there. Sine minus sine. Let's see what we got on the paper. Sine minus sine is the last one. So we got alpha plus beta. 3 and 7 is 10. Divided by 2 is 5. And then we have alpha minus beta. 3 minus 7 is minus 4. Minus 4 divided by 2 is minus 2. Sine is an odd function. That means when you plug in a negative value, That's the same thing as multiplying the entire function by a minus sign and putting in the positive value. So we can take this minus sign and stick it all the way in the front. Do not simplify. Uh-oh. Oh, geez. Really? Do not simplify. I guess they didn't want us to add these numbers together? Really? 3 plus 7? That's just too much effort for us. I guess this is what they're saying. 3x plus 7x divided by 2. And then this one, we did alpha minus beta, so oh, did I miss what do you want, MyMathLab? What is it? Really? All right. So they applied the even odd identity. Oh. I forgot to take the minus sign out of my answer because I applied the even odd identity. All right. So that was my fault. I applied the even odd identity. That's how I got the minus sign there. I'm jumping too far of what they want. I'm going too far ahead. All right, let's try this again. And I'm not going to jump ahead. So we got cosine of some number, another number, alpha, beta, cosine minus cosine. That is the second one. That one does have a minus sign in it. And do not simplify. All right, so I'm just going to plug it in and do nothing with it. 3 plus 7 divided by 2. 3 minus 7 divided by 2. Seems like kind of a pain. But I guess they want to make sure you're doing all the steps. All right. I didn't do anything extra. There you go. Okay. So now, obviously, we need to simplify these to because now they say simplify your answer. So let's look at the numerator again, which is ultimately what I had before, but I guess we'll go through it again. 3 minus 7 is minus 4. Minus 4 divided by 2 is minus 2. 3 plus 7 is 10. 10 divided by 2 is 5. Sign is an odd function, so the minus sign can pull out in front of the sign. That's the numerator of our entire identity. The denominator is the second one here. And that one so 3 plus 7 is 10, divided by 2 is 5. 3 minus 7 is minus 4. Minus 4 divided by 2 is minus 2. We have the same deal again, odd function. We can pull the minus sign out. This function's already minus, so pulling the minus sign out will make it positive. And this is the denominator. So we got this for the numerator. And then we have this for the denominator. So the 2's will divide out. The signs will divide out. And we're left with minus cosine 5x over sine 5x, which is otherwise known as cotangent. So that all cleaned up pretty nicely. Oh no. There's a numerator and denominator here. Uh-oh, I might have gone too far again. I think actually that's might be what they want. It is. All right. And then cosine over sine, that's a quotient identity. And the last one. So it's telling us to start with the numerator. So it's guiding us in how they want us to solve the puzzle. So we have sine of alpha plus sine of beta. Alpha is x, beta is y. We'll look at our sheet for sine plus sine. Third one. So alpha plus beta divided by 2. Cosine alpha minus beta divided by 2. And it looks like that's, I'll try not to go too far. It looks like that's what they want. I guess I'm worried about going too many steps ahead here for what they want. I think they just want us to do this one maneuver first, which, I mean, it is the first thing you got to do. So it's not like it's a bad step. And we're going to do, okay, so here's our numerator. So we'll come back to that. We'll do the same thing for the denominator, which is sine minus sine. So let's look for that one. Sine minus sine is the fourth one. So actually, here's the numerator and the denominator. So sine minus sine, the fourth one here. We have alpha plus beta divided by 2. And then sine of alpha minus beta divided by 2. All right, now they want us to look at the entire fraction here. So I got my sloppy division bar there. And the 2's will divide out. These arguments, the argument is the entire expression that goes in the function here. These arguments are the same. They're both x plus y divided by 2. And sine over cosine is tangent. Likewise, same arguments, x minus y over 2. And cosine divided by sine is cotangent. Okay, here it says divide out the common factors. All right, well, the only common factor was 2, which means we got to type all of this again. And finally, there it is, the tangent cotangent. And sine divided by cosine going to tangent is again the quotient identity. You know, it's good to know the terminology. I don't test that on a test. I don't ask these type of questions. It's good to know the terminology. The truth is, if you use math like this, you'll learn the terminology. And there is the last one.